we are given a quadratic function, h of x, as well as its gradient function, h prime of x. Right, so we have a negative quadratic, and as we'd expect, a negative linear graph is the derivative, right, the gradient function. Our task is to find the equation for h of x. You must use calculus to obtain your answer. Alright, so this is a bit of revision essentially for graphs topic. So looking at our quadratic, if we knew the turning point, we could write the equation in vertex form, right, and substitute in the point 0, 4 to solve for k. Unfortunately, we aren't given the vertex, we aren't even given the x-intercepts, we're literally only given that one point. So that tells me we will need to look for the equation of the gradient function, h prime of x, anti-differentiate, and then solve for h of x. Right, and if you didn't see that, this question is very hard. So let's just, take stock of what you know, what don't you know, and then how can you get to that. So drawing our attention to h prime of x, we know it's a straight line. Wonderful. We can find the equation of the straight line. Yeah, you'll remember for the equation of a straight line, y equals mx plus c, we are given the y-intercept, so c will equal 2, the gradient, the rise over run between 2 points, so we go down 2 is our our rise, and to the right 3 is our run, so our gradient is negative 2 over 3, giving us our equation of the line as y equals negative 2/3 x plus 2. Alright, and now that's not calculus, right? That's just finding the equation of a straight line. So our next step to find the equation of h of x is to anti-differentiate. So h prime of x we just found was negative 2/3 x plus 2. So we can anti-differentiate to find h of x. So negative 2/3 x, when we anti-differentiate, we add 1 to the power and we divide by the new power. The antiderivative of a constant is that constant times x, and when we integrate or anti-differentiate, we have this unknown constant plus c. So reminder, the derivative of a constant is 0. However, the antiderivative of 0 could be any constant, which is why we write plus c. Okay, so just simplifying that a bit, negative 2 over 3 divided by 2 is the same as negative 1/3. And I'm just showing you where that comes from. So when we have a fraction divided by a number, for example 2, it's the same as divided by 2 over 1. And when we divide fractions, it's the same as multiplying by the inverse of the denominator. Right? Oh, that's not the inverse. The inverse of the denominator, and those 2's would cancel, and we're left with negative 1/3. Of course, you can check on your calculator. So we have negative 1 over 3 x squared plus 2x plus c. Alright, and if you got that far, that is achieved, because you found an equation of a straight line and you anti-differentiated. However, I'm sure you're looking at your screen and being like, wait, we have not found h of x yet. Right? Quite right, we need to find c. So find c. Now to find c, we need to use a point on h of x, which, how convenient, they gave us a point at 0, 4, right, the y-intercept. So let's use that point, which has an x value of 0 and a y value, or an h of x value, of 4. So substituting those in for h of x goes 4, in for x goes 0, and we see that these two terms go to 0, and we're left with c equals positive 4. And then putting it together, so therefore h of x is what we had, negative a third x squared plus 2x. Instead of plus c, we write plus 4. And if you got that far, that is the merit component.